I quickly want to go over some special cases. You have your perfect square trinomials, which you saw last time. A plus b quantity squared, this is what it looks like. You need to have this pattern memorized. A minus b quantity squared looks like this. You need to have it memorized. A difference of squares, a squared minus b squared. We do a plus b and a minus b. This must be memorized. The last one, sum and difference of cubes. I want you to recognize it when you see it, and I want you to be able to follow the formula, but I don't expect you to memorize this one. Now we're going to start factoring. This is the opposite of foiling. It's like foiling backwards. And really what you're doing is you're looking for the numbers that you can factor out, so the greatest common factor of each term. Please understand, I do not expect you to write out prime factorization and circle things and all of that stuff. I expect you to simply be able to recognize what's happening. So when I start with this first problem, I know that there are 3 x's happening here and 2 here. That means I can factor out 2 x's. There's a 3 here, and this is 15, so I could factor a 3 out of this. So what that looks like is I know I can say 3x squared times what will be left over here. If I divide by 3x squared, well, I'll be left with a single x. And when I look over here, what will be left over when I divide by 3x squared? I'll be left with just 5. So this is now factored. If you can't see this, then you will need to write out prime factorization. So you're looking for the greatest common factor of each term. You're going to divide each term by that factor. So now we look at some special cases. I've got y squared minus 49. That is a difference of squares. So I know when I have my 2 binomials, I'll have y and y. The square root of 49 is 7. One of them will be added, one will be subtracted. Looking at this one, this is a sum of cubes. Now, I did tell you you were not obligated to memorize the formula, but you had to know how to use it. So this is the formula. A cubed plus b cubed is equal to a plus b times a squared minus ab plus b squared. Now I'm going to tell you this right now because a lot of you are going to say, well, isn't this just a perfect square? No, it is not. If it was a perfect square, there'd be a 2 here. So for our sum of cubes, in this case, I could rewrite this as a cubed. That's easy enough. 8 is 2 cubed. So a is a, but b is 2. So this gives me a plus 2 times a squared minus 2a plus 4. Sometimes we do what's called factoring by grouping, meaning we're going to put things together that have the same kind of terms that we can factor out. You have a few options with this one, but for what we're looking at here, I'm going to group together like this. So from the first set, I see that I can factor out an x. So that gives me x times y plus 5. And from the second one, I see that I can factor out a 3. So that gives me 3 times y plus 5. Now what we can do is combine the 2 factors to give us x plus 3, because both x and 3 are being multiplied by y plus 5. Right? There's your y plus 5, y plus 5. It's only because these are the same that I can put these two together. Now for the last one. This is a special case that I do expect that you're going to be able to recognize. I've got some perfect squares going on here. One thing that a lot of students forget is that 1 is a perfect square. It's also a perfect cube. So when you factor this, I always set up my 2 sets of parentheses. And what I can see is a squared. So that's 2m squared. And then 2ab. So that's 2 times 2m times 1. And then b squared is 1 squared. So here's what that's going to look like. I have 2m and 2m, 1 and 1. If I wanted to check this, 2m times 2m, that's 4m squared, plus 2m plus 2m, that's 4m plus 1.